everyone. My name is Eugene Fidelin, and as you might heard, I'm working as a front-end architect at Marktplaats, which is now part of Adevinta. And my topic for today is about building Node.js BFFs and how we paved our way to a better micro-frontends. So it's going to be like a bit of a personal story of how front-end architecture evolved over time in our company. I hope you find it useful. So before I start deep diving, I want to give you some brief understanding about what is Marktplaats. Well, I hope if you live in Netherlands at least for half a year, you know that company. In a nutshell, it is the biggest trading platform in the Netherlands with over 9 million unique visitors monthly and almost like 19 million live ads. So you can imagine that whatever we build here, it impacts huge amount of users. So let's start with some definitions. So in my talk, I mentioned micro-frontends. So what's that? So there are a lot of different opinions about that, but the definition that I prefer the most is that micro-frontends is an architectural style where independently deliverable front-end applications are composed into a greater whole. So I have highlighted the key statements here, which are independently deliverable and composed. So let's see at this diagram. I think it will show it much better. So you can have a lot of micro-frontends. Each has its own source code, each has its own build and test pipeline, and it is delivered to production independently, and then somehow it is combined in a bigger application. So how those micro-frontends can be composed into a bigger one? So there are different approaches to that. The first one is infrastructure way. So that's, I would say, the most easiest, but maybe a bit of old-fashioned way. So you might have an HTTP server that routes requests. And in this case, the minimal deliverable is one page. If you want to build something smaller than one page and still deliver to production independently, you might need to use something like iframe or that, something like that. Another approach, which can be used in combination with the previous one, is the build time composition. In this case, you can build a standalone application, think about header or footer, and reuse them in multiple front-end applications. But every time you want to make a change in those applications, you need to redeploy all the services that are using it. And the last one, runtime composition, which is the most modern way. And in my opinion, it will eventually replace the build time composition. But nowadays, it requires some support from libraries or frameworks. So at Marktplaats, at the moment, we use a combination of infrastructure and build time composition on production. Our journey started almost 3 years ago in 2019. So at that time, these were the two available options. But at the moment, we are investigating Webpack Module Federation to do the runtime composition as well. So another substantial ingredient of our approach is backend-for-frontend, or BFF in short. So BFF is a pattern where each frontend or micro-frontend application has its own backend, whose purpose is solely to serve the needs of that frontend. So if you look at this diagram, I think it should be much easier to understand. So you have multiple front-end applications. Each of them has its own backend for front-end, and that backend for front-end communicates with downstream services or databases or whatever you have as a data source. So why do I think is why BFF might be a best friend for the micro-frontends? So in our case, it enables us to do the following things. So first of all, customizable API authentication authorization. So imagine that you want to have a different way of authenticating the user in your front-end application and different one whenever you talk to your API. So in our case, we have to run our newly built BFF side by side with the legacy application, which has a very old-fashioned way of having a cookie to authenticate the user. But with APIs, we want to talk using the token-based authentication. So the BFF approach allows us to separate these two things. The next one is flexible A/B experiment setup. So whenever we build a feature, because we control both server-side and client-side part of the things, we can decide where to build this feature. We can build the experiment fully client-side, or we can build it server-side and not expose any code at all to the client-side if experiment is turned off. Highly tailored data fetching and aggregation, I would say that's the most important feature of BFF in general. So basically, that might be the only purpose why you want to build the BFF. So with BFF, we can run multiple server-to-server calls to our downstream APIs in parallel and change the data and expose it only in the shape and in the way that is most suitable for our front-end application. And the last but not the least is the server-side rendering. So because we use the same language, in our case, it's Node.js on the server, we are able to render some parts of our client-side application on the server side whenever we find it's needed. So for example, for some critical functionality that has to be rendered as fast as possible, or for example, if this content is important for SEO. So when our journey started 3 years ago, what we had at that time. So we had 3 huge monolithic front ends, which were really tightly coupled with the backend service. So whenever you made a change in the front end, you also were touching some business logic. There was no clear ownership of that code base because it was huge. Different things were touching different areas of that code base. It was really hard to track, okay, if you change this piece of code, what it will impact, or will it have any impact to other teams. That also leads to that business logic was basically spread across the whole code base. So you can really separate the view layer. Even in the view layer, you will find some rules that belongs to the business logic. We also at that time had no support for multiple tenants and languages. So Marktplaats was the only, like the Dutch only platform. At the moment, we also be able to serve Belgian platform with French and Flemish languages. At that time, we didn't have this feature. And we had very fragile builds. So we heavily relied on end-to-end tests. And whenever we want to deploy this huge monolith, I remember time when it took us maybe a week or even like a couple of weeks to get this green build. So you can imagine that it caused a very long time to market, which made our business not happy. And what made our developers not happy is that we had very old and legacy JavaScript stack. And on the server, we had even less attractive piece of technology, which is JSP, Java Server Pages. I would say it was a gray area. So for the front-end developers, yeah, you would rather work with React, but yeah, JSP is not what you want to do. And for the backend developers, they don't say, oh, okay, JSP is more to the front end. So, okay, guys, you're front-end developers, you should deal with that. So where we are now. So after this migration project, we splitted those huge monoliths into very small BFFs. At the moment, we have more than 25 of those. And usually each BFF is tailored to a specific step or like set of steps of a user journey. You can think of, for example, the BFF that serves the search page, or the BFF that serves the form that allows you to place an advertisement, or another BFF that allows you to log in and to log out from our platform. That also helped us to clearly separate the ownership. So each BFF now has one team that owns it, which makes it much easier to make any decisions, and for that team it makes it easier to move forward. We also fixed issues with downstream APIs. So we said, okay, APIs is our anti-corruption layer. So any business logic should live in APIs, and in the BFFs we have only view logic. We also built in support for multiple tenants and languages, which was an important requirement from business. We were able to achieve stable builds because now we rely much more on unit and integration tests and much less on very fragile end-to-end tests, which helped us to have shorter time to market. And by having modern JavaScript, TypeScript, and also modern frameworks on the server and on the client, at the moment, I hope we have much higher developer happiness and productivity in our teams. So in this diagram, you can see some architectural changes that we did during this migration. So on the left, in this red rectangle, you see like a monolith web front end as it was before. And it was splitted into what you see inside the green rectangle. So as you might see, the one old monolithic web front end was split into multiple web BFFs and multiple APIs. And this allows us to solve a lot of problems. So first of all, it allows us to do this monolith migration in an incremental way. So we were able to migrate page by page by moving each page to a separate BFF. And this focus give the cross-functional teams ability to deliver quicker without worrying that by doing something in their own BFF, they will somehow impact other teams. So that reduces the chances of regressions. So overall, it amplified the performance of deliveries. So on the right, you might see that there is also mentioned app BFFs. So we also decided to use the same BFF pattern to serve data for our mobile applications, but it's a topic for a separate talk, so I'm not going to touch it anymore. Yeah, as I mentioned before, one of the main achievements is that during this migration, we were able to split the business logic and keep in APIs and keep BFFs clean, so they only contain the view logic. So if we zoom into the BFF and the front-end application and what it consists of, so this is an example, a very high-level overview. So in its heart, we have an Express.js application, which has a very, if you're working with Express.js, it has a very familiar structure. So you have a set of middlewares that parses the incoming requests. You have some API client library that makes a request to downstream APIs to get some data. Then you have your route handler that can or cannot do some server-side HTML rendering. And then you return this data to your web application. So inside the same repository, we also have a code for our client-side web application, which during the build step, it is deployed to CDN, so it serves much faster. And of course, to make it configurable, we have translations, properties included into the front-end application during the deploy steps. And during the work, this server part and client part of the application that produces a lot of metrics, a lot of logs, which are important for us. And I will cover this topic a bit later. So if we are talking about developer experience, so how the BFF pattern helped us to improve it. So one of the biggest achievements was that at the moment, it's very easy to start developing the BFF, because the BFF itself is just a Node.js project. Usually it's quite small, so imagine like few pages, so the code base is not very big. You can easily run it in isolation on your local machine. There is no hard dependencies on other services. For the data, you can consume API from any other environment. So think about integration environment, demo environment, or you can also create your own cloud environment. We call it dev tenant, where you can have your own set of data and you can connect BFF that is running on your local machine to that environment, consume that data, and develop the feature. What helped us to grow our front-end developers is that at the moment they're capable and they're able to write both server-side and client-side code. So whenever we onboard a new developer, we also give him some knowledge, bootstrap in Node.js, and because this option is available to you as a developer, you can make much better decisions about how to implement a certain feature. So you're very flexible in that. So you might start building a pure client-side feature, but while developing it, you might understand, okay, the requirements are changing. So some functionality might be much better to move to the server-side code. And because it's in one repository, it's one language, you can much easier do it. So you just move files from one folder to another, and voila, the code is running on the server instead of the client. So we also have the Swagger documentation, which is our contract between BFFs and APIs. It's also a contract between front-end developers and back-end developers, because our back-end developer is responsible for building those APIs. Well, to be honest, we can do better here. So documenting, so the Swagger documentation at the moment is missing some, for example, the type definitions are not so strict. So our end goal to make it as good so it can be used for example, for automatically generating TypeScript types out of Swagger. So for the moment, you can do it, but those TypeScript types are not really usable. So that's why for now we create those types manually and we share them between server and client-side code. And as I said, because we use the same language for the client and for the server, and we use the same language across all the BFFs in our platform, we can reuse a lot of code. So internally, I think we have more than 50 libraries in total, which are responsible for different aspects, and they are all actively reused in all the projects. And it also helped us to come up with a clear PR reviews agreement. So usually the team owns one BFF and keeps developing that BFF. And whenever, if you want to have a contribution to a BFF that's being owned by a separate team, we have an agreement so you can do it without being blocked for too long or without blocking the other team. So I touched a bit what we share and how we reuse code. So these are a few examples. So for example, for the client side, the most important things that we share is we share a lot of styling, fonts, images. So this is to ensure that our UI looks consistent across all the pages. And we achieve it by using the design system, which is created by our UX designers. And based on this design system, we create an exact implementation of those components using React. We also share those components, but we also share much bigger pieces of code. So for example, we share header application, like login dialog, the footer application, and then we use them during the build time. So this is an example of the build time composition, that this React application, they become part of each front-end, a bigger front-end, and being delivered. And of course, we share a lot of type definitions, TypeScript definitions. On the server side, we share, I think, even more. We share all the middlewares to parse the incoming request. We share all the API clients. So this is the library that allows you to make a request to the downstream API. We have an engine that allows you to do server-side rendering for React. And of course, we have libraries that collect metrics, logging, tracing. And we, of course, also have a lot of types for the server-side code. If we are talking about the testing strategy, we also try to streamline and make it faster compared to what we had before in the monolith. As you might remember, I told you that before we had a lot of Selenium end-to-end tests, which were quite fragile and caused us a lot of delays. So instead, we decided to adopt the testing trophy approach described by Can't See Dots. So this strategy encourages you to write more integration tests rather than trying to achieve like 100% code coverage by unit tests. And for us, it works perfectly because it allows to refactor a big chunk of codes without changing a lot of unit tests, but we are still confident that the feature works as expected. And end-to-end tests, we keep them only for some business critical flows. So think about like logging flow or placing an ad flow. And for others, we just try to keep end-to-end tests like to a very minimal level. So ideally, we should not have end-to-end tests for non-business critical flows. And how do we ensure the quality for those? We more rely on monitoring. So that's why alerts and monitoring is important for us. We have a lot of metrics, and whenever we see that a certain metric goes out of range after deploy, we know that, okay, there is something broken, and then we can make a decision either to roll back the new feature or maybe, I don't know, turn off a feature switch or do something else. So how we build and deploy our BFFs. So first of all, we want to ensure that each BFF is being built in the same way. So that's why we share the build config. So this includes the Webpack configuration, Babel configuration, ESLint, TS config. So it means that whenever you switch from one code base to another, you have the same build process, so you're familiar with that. Each front-end application produces exactly the same shape of artifacts, and that also allows us to share the same Docker image. So we have one Docker image which we use to as a container for all our BFFs. As you can imagine, we have a lot of BFFs and we have a lot of dependencies, also internal and external. So for us, it's extremely important to keep all of these up to date. So that's why we adopted Renovate bot, which allows us to keep those dependencies up to date with the minimal manual work. So whenever there is a new version of the internal library, Renovate creates a PR. Each PR automatically triggers a build, and if the tests are green, and if your test coverage is sufficient enough, then the Renovate will automatically merge this PR, and then this feature will be merged into master. We also have security scans by sneak.io, because sometimes there are, well, not sometimes, but quite often there are new security vulnerabilities discovered in some third-party dependencies, and we want to be up to date. So that tool helps us also to update all our projects and keep them safe. And for each build, we also run some quality checks with SonarQube to understand how our code quality evolves over time. So whenever we have a green build, it's time to deploy it, and you can do it in multiple ways. So for example, our platform supports feature and feature switches and A/B switches. So you can wrap your code in a feature switch, and it will be deployed to production, but it won't be available for the end users until you enable it. You can enable it for 100% of users, or you can enable it for some percentage of users using some conditions. And this allows us to gradually increase adoption of a certain feature, keep eye on metric. If something goes wrong, we can roll it back or maybe decrease the amount of users that are exposed, fix it, deploy a fixed version, and keep rolling it out. You can also do a canary release, which is more suitable for some technical changes. So imagine we decided to change the way how our infrastructure works, so then it's more suitable to do a canary release. I would say what makes us confident that we can release the code is that we know that we can roll back in one click. So our rollback procedure is very fast, and you can, in one click, you can return to the previous version of your service on production. And to make sure that everyone has a clear understanding of what's currently running on production, we have a dashboard with an overview where you can see, for example, which version of React is being used across all the BFFs. So you can identify if, let's say, a certain front end is still depending on the older version of the React, maybe it's time to update it, or maybe that service was not deployed for a long time. So this overview gives us an opportunity to make sure that our platform is more consistent from the user perspective as well. So how do we scale, and what are our performance issues? So as I mentioned, each front-end application uses only its own BFF, which means that if we want to scale it up, we can just increase the number of the BFF instances. So imagine that we have a page that serves, I don't know, let's say a logging form, and for some reason it has an increased amount of users coming and would like to log in. So we can just increase the number of that BFF that only serve that specific flow without affecting each other. So we are not in the public cloud yet. We are using our internal private cloud, but in the public cloud, this approach will also save us a lot of money because we can scale by increasing amount of instances for very small services. So we only do server-side rendering for bots, app shell, and only user-critical content. Well, you know that Node.js performance can be quite heavily impacted by CPU-intensive operations. And unfortunately, server-side rendering is one of those operations. So you have to be really careful if you want to render too much on the server. So that's why we do it granularly, only for some elements on the page. And to make it even faster, we are also experimenting with offloading the server-side rendering to a separate worker thread, which is now the more or less stable feature in the Node.js. We do a lot of downstream API calls, and that's why we try to run them in parallel as much as possible. And also, we have Linkerd as our load balancer, and it allows us to route the API call request to the closest or to the fastest instance of the API service that is as close as possible to the BFF. That also helps us to save some round-trip time for server-to-server API calls. And for the client, we heavily rely on CDN. We are using Google Cloud CDN. And because every BFF is using the same build, we are able to provide the same bundle names. So imagine that BFF A and BFF B, they are both using the same version of React. After the build process, they will end up with the same bundle, with the same name, and with the same hash of the file name, which is based on the content. And when you upload it to the CDN, it means that the user will only download this once. So this is one of our strategies towards reducing amount of client-side code that a user has to download when he navigates through pages that are served by different front-end applications. So alerting and monitoring became even more important with with so many BFFs that we have at the moment. And also, as I mentioned before, for non-business critical flows, we dropped end-to-end tests. So instead of we rely on alerts. So for the client, we log errors in the Sentry. So unfortunately, I'm not personally really happy with Sentry because, well, there is a lot of noise caused by errors of the third-party code. Well, if you open Marktplaats, you probably will notice that we have a lot of banners or a lot of third-party scripts like Google Analytics. So sometimes they produce so much noise that it's really hard to find the errors that are caused by your code. We also regularly do performance tests. So we have a schedule, like every hour we run performance test and speed curve to measure important core web vitals metrics about on the pages that are important, for example, for SEO. And we also keep eye on real user monitoring, which helps us to identify any regression in performance in a timely manner. On the server, we have, of course, very extensive access and error logs in Kibana. We send a lot of metrics to Grafana. So one of important ones are Node.js event loop. So we measure how much time it takes for Node.js to execute the next loop of the next round of event loop. And if this time goes up, it means that, okay, there is some CPU blocking operation that prevents Node.js from picking up the next events. We also keep eye on memory usage and how garbage collector works to prevent some memory leaks. Keeping eye on response status and latency allows us to understand like how the BFF behaves. Is it healthy or not? Maybe there is some errors happening in the downstream APIs that cause the BFF also to be slower. And because we have a multi-layered architecture with BFFs, APIs, some backend services, databases at the end, to understand how it works, you need to have a tool like tracing that will allow you to profile your distributed platform and understand like what services were involved in serving a certain user request, how do they behave, where the potential bottleneck is. So in general, what are the pros and cons of the approach that we use here at Marktplaats? So the biggest advantage for us is, of course, huge improvement on time to market for product features. So this is, I would say this was one of the selling point for the business people to actually give us this extra time to work on this project. We have now smaller, more isolated and more maintainable code bases. So whenever we have a new developer, it's much easier to onboard him. It's much easier to switch between teams. But also whenever you want to learn how a certain feature works, it's much easier because you need to read much less amount of code. We think that the current architecture with BFFs is a good fit for scalable organization which has decoupled autonomous teams. So we already had micro services oriented architecture for the backend services, and it works very well. But for the front end, we had one huge monolithic service that was slowing us down. When we split it up, now finally, both on the front end and on the backend side of the things, we have smaller deliverables which fit much better as the team structure that we have. And it also gives us the ability to rewrite parts of our front end in a more incremental fashion. So let's say we are not happy with the way how our search works. So we know that the whole search functionality lives in one BFF, and that makes it much easier to scope this rewrite project, much easier to estimate the complexity and do this actually rewrite instead of trying to attack a bigger piece of code. But of course, it comes with a price. And our biggest concerns are that because of the duplicate dependencies, as I said, imagine each front end requires its own instance of React. At the end, we increase the number of bytes that the end user has to download. But we have ways to mitigate this. For example, as I mentioned before, we are using CDN to make sure that the user downloads as less as possible duplicate code, but still there is a lot of things to improve. Another thing that our autonomies for team, sometimes they are it's too much, and it leads to platform fragmentation and inconsistency. So each team has its own way of working, has its own deadlines, and that's why they can make not optimal decisions, or they might optimize for their local things and not optimized for the whole platform. So that's why at the moment we observe that there are some differences in the way how similar features are implemented in different BFFs. But we have an idea how to fix it. So we want to have, and we already have, so-called front-end improvement team, which should help each of the autonomy team to basically improve their code bases. And with this number of BFFs, we have now extra effort to keep them all up to date. But we have proper tooling in place. It's just a matter of adopting and using it in the right way. And surprisingly, at the moment, we notice that our CI/CD pipeline becomes a bottleneck. So sometimes we do so many deploys to production per day that you have to wait longer just because our Jenkins is not capable of doing so many builds in parallel, so which is funny. So I want to touch a bit on how we make decisions. So in our company, we have so-called vertical autonomous teams, which are focusing on owning a specific feature on our platform. So think about the team that is owning and focusing on building the search experience. Another team is focusing on building the seller experience, so how you place your ad. And each team has front-enders, back-enders, UXers, and so on and so forth. But still, at the same time, we want to ensure that front-enders, even if they work in different teams, they still work on the same product. So for that, we have front-end chapter. And one of the goals for the front-end chapter is actually to support this close collaboration, knowledge sharing between all the front-end developers, doesn't matter which team you're working on. And whenever we have a decision which we want to ensure that everyone adheres to, we use so-called ADRs, so architecture decision records. So this is the way how we capture those decisions and make sure that they are implemented. So next to that, we also have a tech radar, which is a list of technologies, tools, languages, frameworks that we either want to use or don't want to use, or we allow to use in a Muley project. So this is the way how we keep our platform consistent. So for example, we put on hold let's say, the GSP a long time ago, which means that whenever you want to build a new feature, you have to use only React. You cannot use any other framework or technology. So what are our plans for the future? So as I mentioned at the beginning, we are, for now, on production, we are only using infrastructure and build time composition, but we are now looking into adopting the runtime composition, and specifically we are looking into Webpack module federation. The challenge for us is to make it work nicely with server-side rendering, because the pages that will benefit most from this runtime composition, they also have to be rendered on the server, so we need to make it work nicely both on the client and on the server. So the goal for us is to build some POC, collect metrics, learn how it works, understand what are the risks and challenges. And at the end, we want to achieve the following goals. So we want to make one single React app to be our minimal delivery artifact. So at the moment, our minimal delivery artifact is a complete page, and the complete page at the moment consists of several React applications. So instead of, we want to be able to deploy even more smaller bits. And we want to be able to update shared features like header and footer with a single deploy. So now it's done via build time composition. So whenever you do a change in the header, you need to redeploy, rebuild all the 25 BFFs, which takes time. And it causes some inconsistency on our UX UI for the time being. So here you can find some useful links, which I also used when I was preparing this presentation, but also when we were building our own implementation of these BFFs and micro-frontends. And I would like to thank you for your time. Thanks for inviting me, and I hope you find it useful, or at least interesting, and looking